Okay, so this is the 2024 Pure Paper 1. It's a re-upload because the first one didn't have any audio. So let's get straight into it. Question 1. Given that x minus 3 is a factor of g of x, we have to find the value of k. So that basically is telling us that if we put 3, we should get 0. So if we do that, we'd get 3 cubed minus 20 times 9 plus k plus 17x plus k, and that's 3, sorry, that should equal 0. So let me use the calculator. So we get 3 times 3 cubed, 81 minus 180 plus 3k plus 51 plus k equals 0. So then we just add the like terms. 81 plus 51 minus 180, we get minus 48 plus 4k is equals to 0, minus 4k equals minus 48, k is equals to 12. That's question 1. Question 2, finding ascending powers of x, the first 4 terms of the binomial expansion of 1 minus 9x to the power of half. So I think the formula was 1 plus nx plus n minus 1 over 2 factorial x squared, and it says to find the first 4 terms, so we need to do the next term as well, which is n minus 1 n minus 2 over 3 factorial x cubed. Now we're given our power is half and our first term is x, so we don't need to do any factorization, we can go straight into it. So n would be 1 over 2 and x would be minus 9x. So we would do 1 plus minus half, or wait, let's just write that as 1 minus half, and then x is 9x plus half minus 1 over 2 times 9x squared plus half minus 1 half minus 2 over 6, and then 9x cubed. So I'm just going to use my calculator to simplify this. Okay, and then we get that, and this would come out as 1 minus 9 over 2x. That part would come out to minus 81 over 8x squared minus 729 over 16 x cubed. Okay, for part B, it says give a reason why x is equals to minus 2 over 9 should not be used in this expansion to find an approximation to root 3. So for these types of questions, the general way is to do these is just saying that if we know that 1 plus, let's say, a to the x to the power of b, then the range of validity would just be the modulus of ax to be less than 1. So in this example, we have minus 9x. So that would be minus 9x, the modulus of that less than 1. 9x is less than 1, so x would be less than 1 over 9. So in this example, the modulus of x is basically less than 1 over 9, and x is equals to minus 2 over 9 does not fall in that range. So you just say that modulus x less than 1 over 9, 2 over 9 not in range. And that's question 2. So let's going on to question 3. Show that alpha lies in the interval 3.6 to 3.7. So for these questions, you would have to first find the value of f of 3.6. I'm just going to save some time and quickly do it on the calculator. And we get minus 0.686. And then f of 3.7, we get (0.211). Now this is less than 0 and this is greater than 0. So what you would write, you would say change in sign in the interval which is continuous. Therefore, root between 3.6 and 3.7. Okay, so for part B, it just says to find the derivative. So the derivative would just be the derivative of x, which is 1, and then the derivative of tan would be sec squared x, but you're using the chain rule, so you'd have to multiply inside the bracket by the derivative of the bracket, which would be half sec squared half x. So that would be your answer for part B. Now for part C, it says using 3.7 as the first approximation for alpha, use the Newton-Raphson to obtain a second approximation for alpha. So the formula for that is xn plus 1 is equals to x to the n minus f x to the n over f dash x to the n. So it says that the approximation for x is x1, was it? Yeah. x1 is equal to 3.7, and it's asking us to find x2. So we know x2 is therefore going to be 3.7 minus f of x to the 1, which is 3.7, over f dash 3.7. Now we just use the calculator and find the value. So you would plug in 3.7 into that. So you do 3.7 plus tan half 3.7, and then you divide that by plugging in 3.7 over here. And when you put that on your calculator, you should get alpha to be 3.672, and that's question 3. So let's go on. Okay, so for question 4, it says that given that y is equals to x squared, use differentiation from first principles to show that dy over dx is equals to 2x. So the formula for this is that dy over dx is equals to the limit of h as it tends to 0 of f of x plus h minus f of x over h. Now in this example, we're given y is equals to x squared. So we'd say that x plus h squared minus x squared over h, where the limit in h tends to 0, and this, let's just copy this as LHS. Then you'd get x squared plus 2xh plus h squared minus x squared over h. X squareds cancels out. And then we can factor out a h to say 2x plus h over h as the limit h tends to 0. H is cancelled out. LHS is therefore equals to 2x, as we've said that h is tending to 0. So that's your answer. So that is question 4. Question 5, the function f is defined by 2x minus 3 over x squared plus 4. Show that it can be rewritten as that. So we can say that f of x is equals to 2x minus 3 over x squared plus 4. I'm just copying the question. I would say v is equals to x squared plus 4, and then v dash is equals to 2x, because we're using the quotient rule here. U is equals to 2x minus 3. U dash is equals to 2. Now, the formula for the quotient rule is vu dash minus uv dash over v squared. Now, let's compute this. We'd get 2 times x squared plus 4 minus 2x times 2x minus 3. 2x minus 3 over v squared, which is x squared plus 4 squared. So it's already starting to look something like that. Now we can further expand this, and we'd get 2x squared plus 8 minus 4x squared plus 6x, over x squared plus 4 squared. And then when we do it further, we get minus 2x squared plus 6x plus 8 over x squared plus 4 squared. Okay, so for question 6, this is just a modulus question. So for this one, for part A, it says to find the coordinates of P. So for these questions, I like to think these two lines are separate, and we know that this is a modulus sign. So for one of them, you can just take it normally, ignore the modulus, and just rewrite the line as that. And then that would be this line going upwards because the coefficient of x is going to be positive. Now for this line, you would just negate the modulus sign or negate whatever's in the modulus. So it would be 3 times minus x plus 2 plus 5. Now point P basically is just where these two lines intersect. So we would solve that and you would get 3x minus 6 plus 5 is equals to minus 3x plus 6 plus 5. So you would get 6x is equals to 12, because 11, and then this would be minus 1, that would become 12. So x would be 2. And then when we plug 2 back into the equation, we would get 5, because 2 minus 2 is 0. 3 times 0 is 0 plus 5. So y is equals to 5. Okay, part B says solve the equation 16 minus 4x is equals to 3 mod x minus 2 plus 5. So we know that 16 minus 4x will be just some line like that. You can use your calculator to double check. So once we know that 16 minus 4x would intersect the modulus graph when the gradient is positive. So we can solve this equation as if there were no modulus because we're using the positive coefficient of x anyway. So we can say 16 minus 4x is equals to 3x minus 6 plus 5. 7x is equals to 17. X is equals to 17 over 7. That's part B. Okay, so a line has equation y is equals to kx plus 4, where k is a constant. Given that L intersects y is equals to 3 mod x minus 2 plus 5 at 2 distinct points, find the range of values of k. Okay, so there's some line which passes through 0, 4, and it intersects this modulus graph at 2 points. And we need to find the gradient of this line, or the range of values of the gradient. So what can we say? We can say that k would have to be less than 3. But why? We know the gradient of this line we calculated from this modulus graph is it would be 3. So if the gradient of k, or if k was 3, that would mean that this would just be parallel, meaning there's only one point of intersection, and it specifies that we need 2. So we can say that k is less than 3. But for the second part, we have to say that the gradient of this line has to be greater than whatever the gradient is at P. So let's say the gradient was this. This is all less than P, and there's no point of intersection. So we need to find the value of K at P, and we have to specify that the gradient has to be greater than this for there to be an intersection. So P we calculated as 2, 5, and we need to find the value of K. So y is equals to kx plus 4. P is equals to 2, 5. 5 is equals to 2k plus 4. 2k is equals to 1. K is equals to half. So therefore, our values, once again, would be greater than half, because let's say at this point the gradient is just half. It has to be greater than half to have the two intersections, but at the same time it has to be less than this line. Sorry, less than this line. Yeah, less than this line for there to be two intersections. So our final answer would be k is greater than a half, but less than 3. Okay, so for question 7, we're given a tank. It's 1.5 meters. Initially, the tank is full of water. So instantly, I would write when t is 0, what does it say? The depth h would be 1.5. The water starts to leak from a small hole at point L. While the tank is leaking, the depth of the water is modeled by this equation, where t is the time after the leak starts. Using the model, show that h is equals to a e minus 0.2t plus b. Okay, so this is just a standard solving a differential equation. You would separate the variables. So dh over dt, let me just copy it down, is that. Make the dt to the other side. So dh is equals to minus 0.12 e minus 0.22t dt. Integrate both sides. You get h is equals to minus 0.12 e to the minus 0.2t over minus 0.2 plus c. Let's simplify that out. What do we get? Minus 0.12 over 0. Minus 0.2. 0.6. So h is equals to 0.6 e to the minus 0.2t plus c. Now we need to find the value of c. We know at t is equals to 0, h is equals to 1.5. So 1.5 is equals to 0.6. E to the 0 would just be 1 plus 5 plus c, sorry. C is equals to 0.9. So your model is h is equals to 0.6 e minus 0.2t plus 0.9. That's part A done. Now part B, find the time taken for the depth to decrease to 1.2. So we just sub in 1.2 and find the value of t. So that's our model. 1.2 is equals to just that. I'm just going to write r. So we know 0.3, taking the 0.9 to the other side, would be 0.6 e to the minus 0.2t. 0.3 divided by 0.6, a half is equals to e to the minus 0.2t. Natural log of both sides is equals to minus 0.2t, because natural log of e is 1, so it would just be minus 0.2t. And then t would just be the natural log of half over minus 0.2. Let's see what we get. Ln half minus 0.2. You get t is equals to 3.4657. But since I'm assuming they would want it in hours and minutes, so it would be 3 hours, but for 0.4657, you just multiply that by 60 to get the appropriate minutes. And that would be 27.5, so 28 minutes. And that's your answer for part B. So A and B done. Okay, so for part C, in the long term, the water level in the tank falls to the same height as the hole. Find, according to the model, the height of the hole from the bottom of the tank. Okay, so all it's asking us is that with time, this water level would basically just drop to L, which is the hole. So we need to find this height. Now, it says in the question that it happens in the long term. So that's your key sort of phrase. So what that's saying is, what is the value of h as t tends to infinity? So in our model, we took our model, what was our model? There it is. Let me just copy it down here. Minus 0.2t plus 9. So we need the value of h as t tends to infinity. So h is equals to 0.6. E, just put in some very large number in your calculator to check. I'd say minus 10,000 plus, sorry, this was 0.9 plus 0.9. Now, let's just check. I'm going to double check in my calculator. What is that? It's minus 1,000. Yeah, so this is just heading to 0. This would just become 0 plus 0.9. H is equals to 0.9. And there you have it. That's part C. Okay, so question 8 is just some functions. I'd say the first 3 parts is just GCSE. Okay, so part A is find fg2. So we just need to plug in this g function into this x component. So fg of x would just be 4 minus 3, 5 over 2x minus 9 squared. And I'm not going to simplify this. I'm just going to sub in 2 directly and get 4 minus 3, 5 over 4 minus 9 squared. And let me use my calculator. 5, 4 minus 9 squared. We get 1. So fg2 is 1. That's part A. Okay, 8b, it says to find g inverse of x. So let me just write down g of x is equals to 5 over 2x minus 9. So for g inverse, you would just let g of x equal y. 2x minus 9. You would rearrange for x. 2xy minus 9y is equals to 5. So 2xy is equals to 5 plus 9y. X is equals to 5 plus 9y over 2y. So g inverse x would just be 5 plus 9x over 2x. And that is your answer. Oh, right. In the mark scheme, it says that you also have to specify that x is not equal to 0. So that would be your part B. So for part C, find g of f of x, giving your answer as a simplified fraction. So g of x is 5 over 2x minus 9. F of x was 4 minus 3x squared. So we just plug in f of x into the component in g of x. So 5 over 2, 4 minus 3x squared minus 9. And then let's simplify. 5 over 8 minus 6x squared minus 9. And then we get 5 over minus 6x squared minus 1. Okay, so for C part 2, it says deduce the range of gfx. So where is it? Yep, here it is. So we calculated g of x, or to get the function, as 5 over minus 6x squared minus 1. Now, for these types of questions where it asks you to find the range, I would say, like, examine the behavior of the function or sketch it out. So you can use your CG50 to sketch the function. So what can we see? Now, we know that the function does actually touch 5. So gf of x always has to be greater than or equal to minus 5. Because as you can see from the graph, if I can trace over it, it does actually touch 5. One sec. Yep, there we go. When x is 0, then y is minus 5. So it's touched minus 5, but it never touches 0. There's an asymptote at 0. So our range would be greater than or equal to minus 5, but less than 0. As simple as that. And then for the last question, part D, find the range of values for k for which these two are equal and have no real solutions. So 4 minus 3x squared is equals to 2x squared minus 6x plus k. First, I would just solve it. Don't worry about it having any solutions or whatever. So 5x squared minus 6x plus k minus 4. Yep, equals to 0. And now you do actually have to use the b squared minus 4ac. And since it has no real solutions, it has to be less than 0, sorry. So that would be 6 squared, or minus 6 squared, 36, minus 4 times 5 times k minus 4 to be less than 0. So 36 minus 4 times 5k minus 20 less than 0. 36 minus 20k plus 80 is less than 0. So 116 is less than 20k. And k is greater than 116 over 20. What does that equal? I'm just going to write it as a decimal. K is greater than 5.8. And that's the answer for part D. Okay, so a geometric series question for question 9. We need to find the value of k. So we know that the common ratio of these two terms will be equal to the common ratio of those two terms. So 9 to the power 7 minus 2k over 3 to the power, divided by 3 to the power 4k minus 5 would be equal to 3 to the power 2k minus 1 over 9 to the power 7 minus 2k. Now, before I cross multiply or anything like that, I'm going to convert everything to the same base, which would be 3. So that would just be 3 squared to the power 7 minus 2k over 3 4k to the power 4k minus 5. This would be the same, and that would just be the same as well because these two are the same. So 3 squared 7 minus 2k. Now I can cross multiply. So rather than expanding it out, I can just write that as 3 squared to the power 7 minus 2k, and this entire thing squared, because there's 2 of those. And that would equal 3 to the power of 2k minus 2 times 3 to the power 4k minus 5. Now we can start simplifying. So let's multiply these powers out. We would get 3 squared, 14 minus 4k is equals to, let's add those powers. We'd get 3 to the power 6k minus 7. Let's simplify further. This would be 3 to the power of 28 minus 8k is equals to 3 to the power of 6k minus 7. These bases are the same, they'd cancel out. 28 minus 8k is equals to 6k minus 7. 21 is equals to, no, sorry, 35 is equals to 14k. K is 35 over 14. And simplifying that was the 5 over 2. And that's your final answer for part A. Hence find the sum to infinity of the geometric sequence. So I think the formula was a over 1 minus r. And the first term is 3 to the power 4k minus 5. So we can just plug in 5 over 2. So I'm not going to write that out. I'll just do that on my calculator. 3 to the power 4 and then 5 over 2 minus 5. You get 243. So A is 243. And your common ratio is still 5 over... No. Your common ratio you also have to calculate. So 9 to the power 7 minus 2. 5 over 2. You get 5 over 2. 81. So you have 81 and you have 243. So you divide those terms and you get a common ratio of 1 over 3. So now you can use this formula. Sum to infinity, 243 over 1 minus a third. And you get 729 over 2. And that's your answer for part B. And now let's do question 10. Figure 3 shows a sketch of part of the curve with equation ax minus x to the power 5 over 2. The curve crosses the x-axis in the point A. Verify that the coordinate of A is 4. So, yep, we just need to say y is 0. So, x to the power of 5 over 2 is equals to 8x. X to the power of 5 over 2 divided by x is equals to 8. This would just be x minus 1. X to the power of 3 over 2 is equals to 8. That is just x to the power of half cubed is equals to 8. So what is it saying? It's saying root x cubed is equals to 8. We can cube root both sides. And then we can say root x is equals to 2. And then we can say x is equals to 4. All of that for 1 mark. I probably overcomplicated it. So that's part A done. Okay, so part B says that the line L1 is tangent to the curve at A. Use calculus to show an equation of the line is that. So what does that mean? That means we can differentiate the curve and we know the coordinates of A. So we can find the gradient. Y is equals to 8x minus x to the power of 5 over 2. Let's differentiate. Dy over dx is equals to 8 minus 5 over 2 x to the power of 3 over 2. And the coordinates of A was 4, 0. So we can plug in x is 4. 8 minus 5 over 2. 4 to the power of 3 over 2. We get 8 minus 4 over 2. 4 to 3 over 2. We get minus 12. So the gradient is minus 12. So we know it would be y is equals to minus 12x plus c. We know the coordinates of A was 4, 0. Let's find the value of c. We can do that. So y would be 0. X is 4. So that would be minus 48 plus c. C is 48. Y is equals to minus 12x plus 48. What did they want? They wanted, so we have to show this exact form. So just rearrange that and say 12x plus y is 48. And that is... Okay, so for part C, it says the line L2 has equation y is equals to 8x. The region R shown shaded in figure 3 is bounded by this curve. Use algebraic integration to find the exact area of R. Okay. So first of all, what I would do with these types of questions is try form some sort of a strategy. So I would first find the area of that triangle. And then to find the region R, I would integrate this curve, this line, this curve between 0 and 4. And then you can find the area of the triangle and then minus this region to get R. Okay, so let's first find the area of the triangle. We need this height and we know this base, which is OA. which was 4. So let's find that height. That's when these L2 and L1 intersect. So 12x plus y is equals to 48. And y is equals to 8x. So y is equals to 48 minus 12x. Y is equals to 8x. Ax is equals to 48 minus 12x. 20x is equals to 48. X is equals to 48 over 20, which is 12 over 5. That's the x coordinate, and we need to find this height, meaning we need the y coordinate when x is 12 over 5. So let's find that. So we know we can use this equation. Y is equals to 8 times 12 over 5, and we get 96 over 5. Let me just double check. Yep. Okay. Let's find this area now. So we know this height is 96 over 5. We know this base is 4. So we can use the formula half times 4 times 96 over 5. Keeping everything as a fraction because I know that I'll need it in exact form. So 192 over 5 is the area of that triangle. Now let's do the integration between 0 and 4 of this curve. So y is equals to, wait, what was it? 8x minus x to the power of 5 over 2. Integral between 4 and 0, 8x minus x to the power of 5 over 2 dx. Let's evaluate it. 8x squared over 2 minus x to the power of 7 over 2, divide by 7 over 2, evaluated between 4 and 0. When we plug in 0, it would be 0, and when we plug in 4, we would get 2 minus 4 to the power of 7 over 2 divided by 7 over 2. So we would get 192 over 7 by only plugging in 4. Now we know the area of that triangle was 192 over 5. We know that is 192 over 7. So 192 over 5 minus 192 over 7. 384 over 35, which is our final answer. That's question 10. Okay, so question 11, probably one of the hardest questions in this paper. It was about this semicircle badge type question. We want to find the exact value of r, and we need to give it in this form. So first, let's sort of think of like a general strategy. You would find the area of this semicircle, and then you can minus this white region, to find the area of that gray part. So we know the diameter of this ABCOA. So ABCOA is 10. So we can first just easily find the area of the semicircle. So that would be pi r squared divided by 2. So pi times the radius, which is 5. So 25 over 2 is equal to 25 pi over 2. Simple. That would give you 1 mark probably, and that's the area of the entire semicircle. Okay, so now for this white part, we need to find the area of this white part. So what I can do is I can split this like that and draw another line from O to get this triangle. Now the main thing to realize is that this is actually an equilateral triangle because we know that O is a center of a circle. And then we also know that A is a center of another circle where OB is the arc. So we know these three lengths are going to be equal. So this would be 60, or in radians it would be pi over 3. This would be pi over 3, and this would be pi over 3. And we know that OB is this arc of a circle with center A, and this also has a radius 5. So we know that would be 5, and since this diameter is 10, this is also 5. So now we know that this sort of shape is a sector, and we can easily find the area of that. We know the formula to calculate just like this part, that part, would just be half r squared theta. So we can say half times r squared times theta. So half times 5 squared times theta, which is pi over 3, would get us 25 times half times pi over 3 gives you 25 pi over 6. Okay, that's fine. So let me just rub this out, draw it again. Okay, so now we've got the area of this entire sector. Now the next step is that we still need to find this little piece here. So what we know is that since these are all 5, because it's an equilateral triangle, we know that this sector is basically the same. That sector is the same as this sector. They're the same exact sort of shapes, and because they have the same radius. So we already know that the area of both sectors therefore will be 25 pi over 6. So we know that this entire thing is 25 pi over 6. So if we just minus the area of this triangle, we'd get the area of this piece here. So the area of the triangle, since the angles are all pi over 3 and the radiuses are 5, we can say half times a times b times sine c. So half times 5 times either sine 60 degrees or sine pi over 3 radians. My calculator is in radians, so I'll just do it in radians. Times sine pi over 3. So you would get 25 root 3 over 4. And that is the area of your triangle. And we need to minus that of that entire sector to get this piece here. So that piece would just be equal to 25 pi over 6 minus 25 root 3 over 4. Let's just leave it for now and not do anything with this and simplify later. Okay, so we've got this entire this region now, because this would just be this sector plus that small piece that we calculated, and we can just minus that of the total area of the semicircle. So let's do it. So 25 pi over 2 minus 25 pi over 6 plus, this is the small piece, 25 pi over 6 minus 25 root 3 over 4. Now you sort of have to be careful here because the calculator will not give you exact form and you need it in exact form. So I'm just sort of trying to calculate in my head. Yep, that should be fine. And now I can simplify it further to give me this plus 25 root 3 over 4. And then you should get, now I can use my calculator. Minus 50 over 6. You'd get 25 pi over 6 plus 25 root 3 over 4. And that is your final answer. Yep. So if you just want to like make sure to give yourself A and B, A you would write as 25 over 4 root 3, and B you would write as 25 over 6, and that's this question done. Let's move on to question 12. Express that in that form, in that k cos theta form, okay? So 140 cos theta minus 480 sine theta in k cos theta plus alpha. Okay, so, I actually don't remember. Yeah, okay, I think I know the formula for this. I think it was k, let's just leave it like that, cos theta cos alpha minus sine theta sine alpha. I just remember those to be opposite if it's cos. So then we can just say, we can just say that's that. Theta, oh, sorry. Sine theta sine alpha minus k sine theta sine alpha, and then we can equate that to 140 cos theta minus 480 sine theta. So your basically essentially k cos theta cos alpha would be 140 cos theta. These thetas cancel out, so k cos theta is equals to 140, and then your minus k, oh my days, k sine theta sine alpha is equals to minus 480 sine theta. So that would just be k sine alpha is equals to 480. Let me just double check if that's right. Yep, it should be. And now let's first find the value of alpha. So if you divide that by that, you'll get tan alpha is equals to 480 over 140. And let's do that. You get alpha is equals to 73.74 degrees. And now you can find the value of k by just doing the Pythagoras. So essentially, if I just quickly prove it, if you just square that and add that, k squared plus cos squared theta plus k squared sine squared theta is just equals to 140 squared plus 480 squared. You would get 250,000. Just take out a k squared, and you'd get cos squared theta plus sine squared theta, which is 1, is 250,000. So k would be equals to 500. You don't need to show this. I just did it just to sort of show how we get there. So that's 12A done. Okay, so for B part I, we know that the maximum number of rabbits in this wood is 1,500, and we need to find a complete equation. So in the first part, it just sort of told us to convert this into that, and now we need to do the same thing for this part, 140 cos 30t, blah, 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 blah. So R is equals to A, what was it? A plus 140 cos 30t minus 480 sine 30t. We can rewrite that as R is equals to A plus, K was 500, cos 30 theta this time, because there's a 30 in front, plus alpha, which was 73.74. Now it says the maximum value was 1,500, and we need to find this model, so we need to find the value of A. So 1,500 is equals to A plus 500 cos 30 theta plus 73.74. And this is the maximum value, meaning cos, this entire thing, would be 1, because the maximum of cos is 1. So 1,500, A plus 500 times 1, A is equals to 1,000. That's part I done, I think. And now it says, write down the minimum number of rabbits in the wood during the year according to the model. So we've got our model as R is equals to, this is I, 1,000 plus 500 cos 30 theta plus 73.74. This cos will undertake a negative value this time. It would be -1, because that's the minimum of the cos graph. So that would be -1. So this time R is equals to 1,000 plus 500 times -1. So this would be, R would be 500. So the minimum value is 500. Okay. So part C, the actual number of rabbits in the wood is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. So in the middle of April means all of January, 1 month, all of February, 2 months, all of March, 3 months, and then mid-April, so 3.5, not 4.5, because when you think about it, like instantly, it might seem 4.5, but it's actually 3.5. So we know our model, is this part C? Yep. Okay, so we know our model was R is equals to 1,000 plus 500 cos 30 theta plus 73.74. We know theta will be 3.5. Take a value of 3.5. And now let's sub it in our calculator and see what we get. 500 cos 30, 3.5 plus 73.74. We get a value of 500.120, and that's approximately 500, which is the minimum we calculated in the previous part. So we would say the model is reliable, and that's part C. So part D, the number of foxes in the wood during the same year is modeled by this equation. The number of foxes is at its minimum after t months. Find, according to the model, the number of rabbits in the wood at time t months. So we need to find the value of the foxes when it's at its minimum. So this would be when this part of the graph would be -1, because sine's minimum is -1. So sine 30t plus 70 is equals to -1. So let's solve this. I just use this cast diagram thing. So sine inverse, I would just find like the basic angle. Everyone has their own method for this. We'd get 90, but we need it in this. So we would do 180 plus 90. Okay, so I would get my final value as 30t plus 70 t plus 70 is equals to 270. 30t is equals to 200. T is equals to 20 over 3. And that's your value of t. Now, we just got the value of t, and we still need to find the number of foxes at its minimum value. And we found out basically the time when the number of rabbits are at its minimum value. So we can just plug in the value of t directly into this equation and see what we get. So we got, where's our final model? Here it is. R is equals to 1000 plus 500, oh my days, cos 30 times 20 over 3 plus 73.74. And now let's evaluate and see what we get. 30 times 20 over 3 plus 73.74. We get R is equals to 1032. And that's our answer for question 12. Okay, question 13. It's an integration question. And we need to show that is basically equals to that. Okay, so it says given that a is a positive constant, use the substitution x is equals to a sine squared theta to show that that integral can be rewritten as that. So the first thing that I would do is deal with the limits, right? So I need to show that the limits of that integral can be rewritten as that. So when x equals a is equals to a sine squared theta. Sine squared theta equals 1. Sine theta is equals to plus minus 1. But we would basically just use theta is equals to pi over 2. Let's double check if that even is right. Yeah, that's fine. Okay, and then when x is equals to 0, we would get sine squared theta equals 0 and theta is equals to 0. So those are our limits done. And now we can actually do some integration. So let's just start off by plugging the value of x in. So let's rewrite it. So pi over 2, 0, x to the power of half, root a minus x dx. And we need to show that. And x is equals to a sine squared theta. Okay, so first I'm going to just start off by not simplifying, but just plugging the x value in. Let's write it. Pi over 2, 0, a sine squared theta to the power of half times by root a minus a sine squared theta dx. Now let's first get rid of our dx. Let's differentiate our substitution to make it in terms of d theta. We would get dx over d theta is equals to 2a sine theta cos theta. Let me just double check, is that right? 2a sine theta, yep. And then dx is just going to be 2a sine theta cos theta d theta. Let me check, is that right? Yeah, that should be fine. And yeah, so now let's rewrite our integral as pi over 2, 0, a sine squared theta to the power of half, root a minus a sine squared theta times by 2a sine theta cos theta d theta. So I can already see that there might be something to do with a sine 2 theta. Yep, something like that. Let's continue. So both of these things are roots, so we can sort of like join them. We can, because this is like a square root, so we can say a sine squared theta times by a minus a sine squared theta is going to be square rooted times by 2a sine theta cos theta d theta. And then let's further simplify this. We'll get, if we take out an a here, we can get 1 minus sine squared theta here. So that would be a cos squared theta. So if we just do that, I'll write it out to make it simpler. A sine squared theta is rewritten as a times 1 minus sine squared theta times by, let's just call this r so I don't have to keep writing it, r d theta. Integrate between pi over 2 and 0. We get a squared, because a and a multiply, and this can be rewritten as cos squared theta. So this would be a squared sine squared theta cos squared theta square rooted times by r. And then let's integrate between pi over 2 and 0. And now that would become a sine theta cos theta times, now let's bring r back in, which is 2a sine theta cos theta. Now let's actually examine what our final thing is. So they want to take out a half a squared and they want to show a sine squared theta, 2 theta. So yeah, we can do that. We can definitely do that. So first I would say let's multiply everything out. Let's just multiply it out. Let's see what we get. Am I making any mistakes? No. So it would be 2a squared sine squared theta cos squared theta. Or if I write that, yeah, actually, no, never mind. That was bad. Yeah, we can rewrite this as a half a sine 2 theta because sine 2 theta is, what is it? It's 2 sine theta cos theta. So that can be rewritten as a half a sine 2 theta. So a half a sine 2 theta times, and that thing can be rewritten as a sine 2 theta. So that can integrate between pi over 2 and 0. We get a half a squared sine squared 2 theta. And now we can just take our half a squared because this is a constant. Oh my days, mind my d thetas, which I keep forgetting. D theta, and then you can integrate that, pi over 2 and 0, sine squared 2 theta. And that should be what we wanted. Yep, okay. Part B, hence use algebraic integration to show that that thing can be rewritten as some sort of pi multiple. So it's basically just asking us to integrate this. That's definitely doable. Wait, do we leave it in terms of a? Yeah, okay, a squared. So now let's integrate this. So you can't actually integrate sine squared directly. You have to use the cos double angle identity. So we know that sine squared, how I remember this identity, is 1 minus 2 sine squared theta is equals to cos 2 theta. So 1 minus 2 sine squared 2 theta, because this time we need a 2, would be equal to cos 4 theta. Because you just multiplied this angle by 2, so you would multiply that angle by 2 as well. Rearrange to get in terms of sine squared 2 theta. You'd get this. And now we can just integrate half a squared, integrate between pi over 2, 0 of 1 minus cos 4 theta over 2. A half a squared, integral between pi over 2, 0, a half minus a half cos 4 theta d theta. A half a squared. Now we integrate it, so we write a half theta minus cos integrates to sine, positive sine, so minus 1 over 8 sine 4 theta between pi over 2 and 0. A half a squared. When it's 0, everything is 0, so that doesn't really matter. That half times pi over 2 would be pi over 4 minus 1 over 8 sine 2 pi, which I think is 0. Let me double check. Oh, wait, I have to put my calculator in. Radians, sine 2 pi, 0. So pi over 4, yep. Yeah, times 0. And this would be 0 anyway when you plug in 0. So you should just get pi over 8. This cancels out, so you get pi over 8 a squared. And that should be the final answer. Yep, that's fine. So that's question 13 done. Now we can move on to question 14. A balloon is being inflated. In a simple model, the balloon is modeled as a sphere. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. At the time t is equals to t, or at the time t seconds, the radius of the balloon is r. Write down a differential equation. Okay, so what is it saying? It's saying the rate of increase of the radius is inversely proportional to the square root of the radius. Okay, so it's saying that dr over dt is proportional to, inversely, 1 over the square root of the radius. Is that right? Yeah, that should be right. So for these types of questions, this is GCSE. If you want to equate them, you just let some constant k multiply by some constant k, and you should just get k over root r, and that should be part 1, right? Okay, at the instant when t is equals to 10, the radius is 16, the radius is increasing at a rate of 0.9. Solve this differential equation to show that that is that. Okay, yeah, this should not be too hard at all, given that to show that as well. Cross multiply, root r dr is equals to k dt. Integrate both sides, you get r to the power 3 over 2 over 3 over 2 is equals to kt plus c. And now we actually use the information they give us. T is 10. R is, what was R? R is 16. R is 16, and the radius is increasing. So dr over dt is equals to 0.9. Okay. So from the first piece of information, we know that the radius is 16, dr over dt is 0.9. So we can calculate the value of k. So 0.9 is equals to k over root r, which is 4. So 4 times 0.9 is just k, and k should just be, it's 3.6. Let me check, yeah. 3.6, there we go. So, okay, so r to the power 3 over 2 divided by 3 over 2 is equals to 3.6 t plus c. Now we can solve for the value of c. So t is 10 and r is 16 to get the value of c. 16 to the power of 3 over 2 divided by 3 over 2 is equals to 3.6 times 10 plus c. Rearrange for c, and we get 36. C should be 20 over 3. So then our final model, what do we have to show? We have to, okay, so if we get C is 20, okay. So r to the power 3 over 2 divided by 3 over 2 is equals to 3.6t plus 20 over 3. Now we can see they've multiplied out the 20 over 3 to that side. So r to the power 3 over 2, multiply 3.6 by 3 over 2, you get 5.4t, and then multiply the 20 over 3 by the 3 over 2, and you get 10. Is that what they wanted? Yup. So that's fine. That's your answer for part B. Hence, find the radius of the balloon when t is equals to 20. Give your answer to the nearest millimeter. So I'm just trying to see if there's anything to do with the units that I'm missing. Okay, so it says centimeters. So we would need to convert it to millimeters. So r to the power 3 over 2 is equals to 5.4 times 20 plus, what was it, 10. Let's just solve this. R to the power of 3 over 2, 5.4 times 20 plus 10. Let me check if that's right. Was it t is equals to 20? Yep, t equals to 20, and we just, okay, fine. Yeah, is equals to 118. So it's just the same type of thing again. We know that it's like that is equals to 118. So we can cube root that. So r to the power half can be rewritten as the cube root of 118, which is just going to be, what does it say to give it a sort of an exact form? To the nearest millimeter. So 4.904868, and then we can just square that. Oh wait, no. And we can just square that to give us the value of r. So we would get 24.057731 centimeters. So giving your answer to the nearest millimeter, you would just multiply by 10, I think. Yeah, just multiply that by 10. So 240.57731 millimeters. Okay. Part D, suggest a limitation of the model. So obviously the model is predicting that the radius will increase indefinitely, and it's a balloon. So obviously that won't hold because a balloon will eventually burst. So you can just write that balloon will eventually burst / radius cannot increase indefinitely or indefinitely. Yeah, whatever that word is. Okay. The last question is a proof. Yep, everyone's favorite. Show that k squared minus 4k plus 5 is... Yep, okay, this is not that bad, actually. You can just do the completing the square. So k minus 2 squared minus 4 plus 5. K minus 2 squared plus 1. Since this value is always greater than or equal to 0, therefore 0 or greater plus 1 would just be greater than or equal or positive. I'm not going to write that out, but since we know that for any value of k, this will always be greater than or equal to 0, and then you plus 1, it has to be positive. Okay, so this final question is just this proof by contradiction. We have to prove that there are no positive integers x and y, such that 3x plus 2y times 2x minus 5y is equals to 28. And the start of this student's proof is shown below, and it's like that. And we need to show more calculations and statements. Now, there are many pairs that you can use, but I think if you exhaust all of the different possibilities, you don't need to use the negative ones because it's sort of implied. So if I say that, so it's 3x plus 2y is equals to, so 14 and 2 is already used. So I would use 2 and 14 and solve this in my calculator. And you get x is 2 and y is minus 2. And this cannot be true because y is negative and it says you need positive integers. And now we can test 28 and 1. And we would get 142 over 19, 53 over 19. And these are not possible because these are also not integers. Now the same thing like that. And you would get, this time you would get 61 over 19. And y is equals to minus 82 over 19. Again, they're not integers. And then you test 7 and 4. You get 43 over 19 and 2 over 19. They're not integers. And then you would get 3x plus 2y is equals to 4. 2x minus 5y is equals to 7. You get 34 over 19 and minus 13 over 19. These are not integers and they're also negative, one of them. Negative. Now, you can do the negative one. So theoretically, you could like negate this one and negate this one. And that would also give you 28. But I think in the mark scheme, it says that as long as you solve the different pairs, you don't necessarily need to solve the negative ones for all the marks. But you do need to write a conclusion. So you would just say that since all cases either one of the values are either negative or not an integer, all cases have been considered and hence there a contradiction and thus proven. So that's it for part 2, and that's the 2024 paper 2, and yep.